Abdullah from class 1A, Diploma 3 in Radiodiagnostic Engineering and Radiotherapy, Semarang. How are you guys? I hope all of you are fine and stay healthy. On this occasion, I will tell you about research optimization of direct digital test radiography using CU filtration. First, I will start the presentation from the introduction, the two procedures, the three findings, and finally the conclusion of the research. For those of you who want to ask, just comment below. Thank you. Introduction. The chest X-ray is the most common diagnostic X-ray examination. It is used to evaluate the lungs, heart, and chest wall, and can be used to help diagnose diseases that are in the chest. Over the past 2 decades, there has been a reduction in patient dose for all types of radiographic examination except chest radiography. To minimize the detrimental effects of ionizing radiation in diagnostic digital chest radiography, it is necessary to optimize the balance between radiation dose, image quality through beam filtration was conducted to assess the impacts of additional CU filtration with the GRX1 detector on image quality and dose. Procedure. It is research simulation using phantom anatomy, which was imaged at 4 different beam level of filtration: 0 mm, 0.1 mm, 0.3 mm, and 0.5 mm CU. Exposure was made 5 times each level of filtering. Source to image distance of 118 cm and 120 dVt. Image quality was assessed from all images at each CU filtration level to areas of interest 0.8 mm and 1.2 mm PN using the exposure index, conspiracy index of each PN at different CU filtration levels, signal to radio noise, and pixel density. On the X-ray tube and area dose product, meter is used to measure the dose. The effective dose and risk of exposure to death from cancer are calculated using PC8MC software 2.0. Analysis of variance was used to assess repeated measures of dose and mean pixel density at different thickness of CU filtration. The Bonferroni post hoc test was used to determine whether any level of CU was statistically associated with dose, pixel density, and exposure index. Since the exposure index increases with increasing CU thickness of 0.3 mm at I1512.3. From the nodule simulated in CU filtration, the conspicuity index is carried by the pulmonary nodule. Conspicuity index was 0.8 mm lower than the 1.2 mm nodule. Signal to noise ratio and pixel density have decreased. The patient dose is reduced because of CU filtration, which is 20.7%, 30.6%, 39.79%. At 0.1 mm, at 0.3 mm, 0.5 mm. The risk of radiation exposure indicated cancer death per 10 million people decreased from 5.02 to 4.9 for men and 10.02 to 9.02 for women in 0.3 mm CU filtration. The addition of CU filtration is very beneficial, namely by reducing the dose in the patient and decreasing the rates of radiation exposure indicate cancer death. Conclusion: the addition of 0.3 mm CU filtration with the newly developed wireless termed DXR1 system in optimizing chest radiography reduced 37% of the patient dose. With a wide dynamic range and increased post-processing image in the digital image quality system, the main concur in optimizing imaging procedures in the radiation dose for patients without a decrease in image quality. Good friends, all points from this material are in the research on optimization of digital test radiography directly using CU filtration. What I can learn is the addition of CU filtration to the test radiograph using the DXR1 system where when adding filtration to the digital image quality of the system, it is better to use a conspicuity index, signal-to-noise ratio, and pixel density, not the exposure index. This using a DXR1 system with filtration techniques can balance the radiation dose and image quality for test radiography. From the result of this study can be applied in test radiography with source to image distance is 180 cm and kVp is kept constant at 120 kVp and with the radiation of filtration can reduce patient dose without decreasing image quality. In this study related the two chest X-ray that displays the inner chest to help doctors determine diagnosis such as problems with the heart, collapse in lungs, collapse lungs, pneumonia, broken ribs, emphysema, cancer, and several other conditions. Well, thank you all who have with us said. If there is a mistake, I apologize. Assalamualaikum warahmatullahi wabarakatuh. See you.